Hi, my name is Victor Saxon and I'm the Technical Service Manager here at Selig, and today I'll be talking about application torque and how it affects induction heat sealing. The most important thing that we really need to consider is that we have even contact of the liner on the jar to generate the hermetic seal that we require. And in order to do this, we need to ensure that the automatic capping heads or the hand sealing technique that we use applies consistent pressure, both not only to the cap jar application, but also for every jar and cap that's on the filling line. Okay, so the factors affecting the on torque, what are they? Well, we really need to start with the cap thread and the jar thread, and these really do need to match. And it's actually best if they're designed in tandem at the beginning of the project. If that is done, then we will get the even pressure that we require. In addition, we need to ensure that the cap does not bottom out on the collar of the jar. So we can see, for example, in this application that there's a good gap between the two, and so therefore the pressure that is being generated is not being impacted by an interaction between the two. So what can we do? Well, we've got multiple thread designs that we can have. This application has a single thread design, which we can see here, and it starts there and runs over 360 degrees around the container. And there are other types of threads that we can have. We can have double starts, 3 starts, 4 starts. I'll have here an 8 start thread. And you can see that the advantage of the 8 start thread is that the cap can be removed extremely quickly. But the most important thing is there must be 360 degrees or greater of engagement between the two. Okay, so what happens if we have insufficient pressure? Well, the first thing is that the container will leak. And if that contains a liquid product, then that can be a real problem. But interestingly, what can also happen is if there is insufficient pressure, because of the induction heat sealing process, the periphery of the liner becomes hotter. And so therefore, because there is no heat sink effect of the container on the periphery of the liner can burn. And from that burning, maybe you can generate odor or melting of any plastic components that might be in the liner. So for example, the heat seal might melt or any foam might melt. In addition, for 2-component liners such as Delta Seal or Safeguard, the two halves may not separate properly. Again, what we really need here is we need consistent on torque delivered by all the capping heads in the process. So what happens if we have excess torque? Well, if we have excess torque, then what can happen is we can get a stripping of the thread, particularly if, for example, one of the plastic components within the package is much softer than the other one. But also, we can get bumping of the cap off the top of the thread. So we apply the on torque, the cap screws onto the threads and then over torques and then bumps off the top. And therefore, we get no seal whatsoever and we actually lose the cap. But interestingly also, in today's age where we're trying to lightweight caps and more plastic is being removed from them, caps tend to becoming more and more flexible, less stiff. And what happens here is therefore if we over torque these, we can find ourselves having positions where we have good contact and perpendicular to that areas of poor contact. And obviously where we get that poor contact, we will get a leaker. So a question which is really frequently asked is, how much pressure do I need to apply to get a good induction heat seal? And there's a rule of thumb, and that rule of thumb is really simple. You take the liner diameter, then you take the radius and you convert the radius into inch pounds. So let's say I had a liner diameter of 30 millimeters. The radius of that is 15 millimeters, and so therefore the on torque would be 15 inch pounds. So then say if I had a 50 millimeter diameter liner, then I would need 25 inch pounds. For my next presentation, I will be talking about the importance of the fill height in the bottles on induction heat sealing.